Welcome back. In this lecture, we are going to start talking about light. First, however, let's dwell for a moment on why light is so important. Look around you. Whatever you can see with your eyes, the monitor, the desk, the lamp you have on your table, a picture hanging on the wall, a tree outside the window, any element that exists in reality, we can perceive because of light. Light starts from a light source. The most important, of course, being the sun, hits objects and bounces in every direction. A small part of this light reaches our eyes, allowing us to see an object, an environment, a scene. What we see, we interpret because of our experiences, what we have experienced. A light of a certain type, an atmosphere of a certain type gives us a certain emotion, and what you want to do when you do a rendering is transform a geometric information, so the model that we have created within Blender, into a visual information. So you understand that light is very important. Also, light helps us through shadows to define shapes. If there were no shadows, we couldn't distinguish a circle from a sphere, to give an example. And that's why, even before I talk about material in Blender, I want to talk to you about light. In Blender, we have two different render engines. If we go to the render panel with the camera icon, we see that by default EV is used, but if we click, we see that we also have workbench and cycles. Workbench. Imagine rendering what we see in the 3D viewport. The other two, however, EV and cycles, are actual render engines that allow us to apply materials, apply lights, and so on. EV is more like a video game rendering engine where shadows are calculated more loosely, materials are less complex. Let's say it has a number of machine facilities that allow for real-time rendering. Just as we do when we immerse ourselves in a 3D video game, you can get beautiful images with Eevee, and it is particularly suitable for creating animations precisely because of its computational speed. Cycles, on the other hand, is a rendering engine that physically calculates how light bounces off our objects, using the principles of physics. This will result in a greater computational burden on our computer, therefore longer times, but a much higher final quality. If your intent is to get the most realistic image possible, Cycles is definitely the right choice. Absurdly enough, Cycles is also easier to use. For this part of the basic course, we will always use Cycles. So take care. Remember to set this as your rendering engine. Also, because you will notice that many options change. So if you don't have Cycles set up, you will have a hard time following the lessons because you won't get the options that I will be using on the monitor. Let's change right away. From EV, let's put Cycles. We already see that the list of items has changed immediately, but let's not deal with anything else for now. Well, with that premise done, let's finally get into what lighting is inside Blender. We've previously seen the 4 visualization options within the 3D viewport, and we know that to preview what our rendered scene will look like, we have the 4th option called Rendered. Let's click to activate it. In appearance, not much has changed, just this face of the cube is a little bit darker. To better understand the effects of light in our scene, we in fact need shadows. Shadows help us so much to understand the shape of an object and especially also the direction of the light. So to help us, we are going to insert a plane under the cube so that it can cast a shadow. We move the cube upward, then with Shift plus A, we go to enter a plane. We scale it about 10 times, and finally we see something interesting, namely the shadow of the cube projected onto the plane. Inside the outliner and in the scene, we see that the light source is 1. It is called light. It is the one that is present by default. Now we select it and try to move it. We press the G key and see that in real time the shadow of our cube is changed. As with any object, we have the ability to go and modify the options. We find them here within the properties window. You see, we have this green light bulb icon that we normally don't have instead. If we select, for example, the cube, we see that yes, there is the green icon that opens the data section. However, it has a different shape, the shape that reminds us that we are using a mesh type object. When, for example, we select the camera instead, we see that the green icon changes, precisely reminding us that we have an object of type camera. So let's go back and select our light, and we see the light bulb, which immediately lets us know that we are precisely talking about a light object. In here we find a whole series of options that allow us to vary our light. The first section allows us to have a preview, but we see it directly within the 3D viewport, and the next section, called light, on the other hand, allows us to modify in depth how this light source behaves within our scene. Stop this video for a moment and experiment with these options completely on your own. Do it freely, don't be afraid. As always, nothing will happen. Just experiment a few times and see what happens. I'm going to press these various buttons and going to change these parameters. We see that there are 4 types of light source. The first is point, the default one. It is a light that is radiated in all directions 360 degrees, and we can realize this by putting more elements in the scene. Look at what happens by going to put the light in the center of the cubes. You see that the shadows take the form of rays going in all directions. In contrast, if we select sun as the light source, we see that it changes completely. Meanwhile, it looks much more powerful, and it is. We can vary the intensity of this light with the strength value. Instead of 1000, for example, we set 1 and see that now all shadows go in the same direction. You must know, in fact, that the sun is, yes, a giant sphere, but it is so big that when it hits our planet, its rays are practically parallel to each other. So by convention, a sun-type object will go out and project light rays that all have the same direction. So, the position in space of the sun object does not go to change the direction of the shadows. You see, I moved the object, but the shadows are not changed at all. So how can I go about changing the direction of these shadows? Just go and change the tilt of the light rays. We can do that thanks to this manipulator, this yellow dot. We can click it and drag it. You see, change the direction of the sun rays, change the shadows accordingly. We then have a spot type light. This is a light that allows us to simulate a spotlight. Let's increase the intensity again. Let's increase it to maybe 1000 W. And you see that when we go to point the light at our cubes, the shadows are no longer parallel to each other, and a real cone of light is also formed. This cone can, of course, be varied. We will see perhaps with practical examples how the various parameters go to affect these objects. Of course, do for each type of light some experiments on your own. Don't be afraid, experiment a lot because it is very important. Finally, we have the area type objects. These are very similar to the panels that are used in photographic studios. Imagine a square that emits light. We do not see it now because it is very small, but if we enlarge it, for example, with the size of 1m x 1m, there we can visualize it. If we go and put it next to our objects, we realize that we also have a shadow here that varies from object to object based on its position. There is no longer a cone of shadow, but a kind of boundary line between the illuminated area and the unilluminated area instead. Of course, we can have multiple objects at once emitting light. So if with Shift+A we go to insert an object of type light, we see that we can insert a point, sun, spot, or area. Let's insert a light of type point, for example. So now we have 2 light sources, and however, at any time we can go and vary the type of light always from the properties window. We can vary the color, we can vary the intensity, we can vary the radius, which affects the softness of the shadows. Excuse me for repeating this so many times, but this is really very important here. Experiment. Before we close this introductory lesson on light within Blender, let's do an experiment together. Let's try deleting all the light sources. So let's erase this point type light. Let's erase this area type light. There are no more light sources, so our scene looks completely gray. Yet I point out that the cubes are casting a shadow on the plane. If there is no light, there can be no shadow. Indeed, we could not even see the cubes. We should see a completely black screen. Where then does this light come from? How does Cycles, the rendering engine we are using right now, create these shadows? Does it do it of its own accord to make us see better that the cubes are detached from the plane? No, it doesn't. There is actually another source of light that is present by default in our scene, which is ambient light. It is a light that is not handled by an object but by our virtual world, the world. Right now, no object in the scene is selected, and I'll point out that inside the properties window, we are inside just the world section. You see this red icon representing planet Earth, and we see that our world that we can also rename to our liking, has a gray colored light with a strength value of 1. Now let's try dragging this slider upward to change its color. Let's turn it white. Watch what happens. Here is that our scene becomes much brighter because we have white light coming from all directions. This is exactly the opposite of a point-type light. That is, instead of having light radiating from a single point to all directions, here it is as if we are inside a very large sphere emitting light from all directions. This is a situation that we do not find in nature. However, a very similar illumination to this we can have when we are on a fairly bright day, but with a very cloudy sky. In this case, the light coming from the sun passes through the clouds, is deflected in so many directions, bounces off the objects around us, and comes at us precisely from all directions. The shadows disappear, or at least become very, very soft, exactly as it is right now for the cubes. Again, I invite you to do some experimentation. The options seem to be few. We have color. We can get a colored light, even though it might not make much sense to have a green light, for example, as an ambient light. We have the ability to vary the intensity, and we see that we also have this background item with a number of options that we will see later on, though, when we start talking about nodes. We will stop here for the moment. However, I invite you to follow along in the next lesson, where we will return to modeling practice, having fun, lighting our geometry to see how this becomes much more interesting when the light goes to create shadows, goes to create additional information. As always, I thank you for following, and I will see you again soon.